CPU versus GPU versus TPU versus NPU versus LPU versus DPU, the 6 processors powering modern AI. Every AI breakthrough you've heard about runs on one of these 6 chips. They're not interchangeable. Each one solves a different problem. Here's the map. Processor 1, the CPU, the backbone, Intel and AMD. It schedules tasks, routes them to processors, and runs your operating system. It handles anything, but it's slow at parallel math, can't train large models, and has low AI throughput. The CPU is the conductor, not the orchestra. Processor 2, the GPU. NVIDIA dominates. 16,896 cores running in parallel, fed by HBM3 memory and the CUDA ecosystem. The GPU loads the model, distributes across thousands of cores, multiplies matrices, and updates weights. It powers both training and inference. The downside, 700 watts per card, $30,000 per H100, and complete overkill for small tasks. Processor 3, the TPU, Google's weapon. Built around a systolic array, data flowing in lockstep through a grid of processing elements, 2 to 3 times better performance per watt than a GPU, 2 times cheaper, and it scales to 9,216 TPUs in a single pod. The catch, Google Cloud only, less flexible than a GPU, limited framework support. Processor 4, the NPU, AI in your pocket. Apple's neural engine, the chip in your phone. It activates on-device, uses INT8 or INT4 quantization for efficiency, and returns inference in 5 milliseconds. Single-digit watt power, no cloud needed. Your data stays on the device. The trade-off, inference only, no training, and lower accuracy than a GPU. Processor 5, the LPU, the fastest alive. Groq's chip, 230 megabytes of on-chip SRAM, 0 cache misses, and deterministic execution. It outputs 241 tokens per second, 500 words in roughly 1 second. The catch? Inference only, limited memory per chip, and you need hundreds of LPUs networked to serve a real model. Processor 6, the DPU, the invisible layer. Smart network cards that intercept traffic at the hardware level, handle encryption and firewalling, route storage I/O, and free the CPU entirely for AI workloads. 400 gigabits per second of networking, hardware-level security. You'll never see it, but every modern data center runs on it. So when do you use what? CPU for orchestration and pre-processing, GPU for training and deep learning, TPU for Google-scale tensor workloads, NPU for edge and mobile inference, LPU for real-time LLM serving, DPU for data center infrastructure. The decision comes down to 5 trade-offs: latency, parallelism, power, cost, and scale. Pick the